Hello, I am Kobayashi from Sony. In this tutorial, I will describe the process to create datasets that you will need in developing your own custom image classifiers in Neural Network Console, our integrated deep learning development environment. Using deep learning, we can train systems to classify images based on large amounts of labeled image data, which we call datasets. Links are provided in the description to other videos that cover deep learning in more detail, as well as tutorials on using neural network software. Please see these videos if interested in that content. We will use Neural Network Console to create datasets in CSV format. CSV files are text files describing comma-separated values. These files can be easily created in Excel or using scripts. These CSV files are organized with a first row header and data in the second and subsequent rows. To create an image classification solution, we need two variables that are defined with the header. These variables include an image X variable used as the neural network input and the Y variable representing the image category output by the neural network. The first row header describes the X and Y variables in the dataset. X variables are described in the A column and Y variables are described in the B column. You can create comments by placing a colon after the variable name followed by text. Any text strings that come after colons in this data are ignored by Neural Network Console so that you can create comments to make it easier for others to understand the data. For example, entering X:image in the header creates a variable named X with a comment indicating that this variable represents images. Enter data resources individually in the rows under the header. For an image classification dataset, enter image file names in column A as variable X and the index of image categories in column B as variable Y. You can use either relative paths from the dataset CSV file or absolute paths for image file names. Supported image file formats include the common formats such as bitmap, JPEG, PNG, and TIFF. The number of input neurons must be consistent in neural networks. The size of input images must also be consistent for image classification systems. For this reason, make sure to use image processing software or scripts to ensure that the size and number of color channels of all images are the same. For the image category index, assign category to each value starting from 0 for as many categories as you need. For example, to create an index of 100 different types of image categories starting with human, dog, and cat, 0 represents humans, 1 represents dogs, 2 represents cats, and so on. If the total number of categories in your index is 100, then the B column as variable Y will need to contain integers between 0 and 99. Using this kind of CSV file, the neural network will process the data and tell us the subject of images, such as image A is a person and image B is a dog. With deep learning solutions, the more data you prepare, the higher the image classification accuracy will be. Making mistakes in classification, though, will negatively impact accuracy. Make sure to enter the correct categories into column B as variable Y. If using Excel to create CSV files, you can simply copy a list of image files from the command prompt and paste them into Excel. Then you just need to enter the Y variable values. If you have some programming knowledge, you can also create simple scripts to create this format of CSV files from a list of image files. Make sure to note that Neural Network Console does not fully support double byte characters such as full-width Japanese characters, so make sure to always use single byte characters for file names, headers, and such. Once you have finished creating the dataset CSV file, Save the file as a text file divided by commas with the .csv extension. These datasets can be created more easily in the Windows version of Neural Network Console by using the included tool to create image classification datasets. To use this tool, create folders representing each image category and place your images in the correct folders. As illustrated here, to categorize images as flowers or food, create a folder that contains many images of flowers and another folder that contains many images of food. Before using the tool to create image classification datasets, the resolution, aspect ratio, color channels, and other parameters do not need to be the same for all images. Once the images are ready, start the Windows version Neural Network Console and click Dataset. Then click the Create Dataset button at the upper left. In Source Directory, specify the path to the folders containing the images we just prepared. In Output Directory, specify the folder used to store dataset CSV files that will be created later. Now we need to configure image size and processing method settings. In Output Width, specify the width. In Output Height, specify the height. In Output Color Channel, select either monochrome or RGB color. In Shaping Mode, select the desired method of processing images that are different in aspect ratio or size from the original image. Trimming processes images by removing parts of the images that exceeded the configured area. Padding processes images by filling missing parts of images with zeros. Resize processes images by resizing images to the specified size regardless of the resulting aspect ratio. Selecting the Shuffle the order of the data checkbox randomly shuffles the order of data resources in the dataset. Data needs to be shuffled because of the mini-batch gradient descent method used in deep learning. As such, this checkbox should normally always be selected. Lastly, we need to specify the file names of the dataset CSV files to be output. With deep learning, you typically need two datasets, a training dataset and a validation dataset. Use the ratio setting at the right edge to adjust the ratio between training data and validation data as a percentage. Once you have finished configuring these settings, press the Apply button. The dataset CSV files will be output to the specified output folder once the data is processed. To use these dataset CSV files with the cloud version of Neural Network Console, these files must be uploaded to the cloud. To upload dataset files, log into the cloud version of the software. From the dashboard, select Dataset and then click the Upload Dataset button. A dialog should now appear. If this is the first time you are uploading datasets, you first need to download the Uploader tool. Press the Get Uploader button to download this tool. Once you have downloaded and started the Uploader tool, copy the token from the dialog box from which you download the Uploader and then paste this token into Uploader. Press the Copy button in the dialog and then press the Paste button in Uploader. Then specify the desired dataset CSV file. The file is now ready to be uploaded. Click the Start button to start uploading the file. The uploaded dataset CSV files will soon be available for selection from the Dataset tab in Neural Network Console. As we have done in previous tutorials, we can now design a neural network to function as an image classifier using your unique image datasets. During that process, make sure to change the size property of the input layer to match the size of the input images. For monochrome images, enter a 1, then a comma, then the height, another comma, and then the width. For color, 3-channel RGB images, enter a 3, then a comma, then the height, another comma, and then the width. The values represent numbers of pixels. If using color images 32 by 32 pixels in size, for example, enter 3, 32, and 32. Neural Network Console allows you to perform a variety of experiments with just sample datasets. If you use your own datasets, however, you can gain a much deeper understanding of deep learning. I hope you will take the opportunity to try different training scenarios using your original datasets.